Welcome. We're talking on a Tuesday afternoon because there's a lot of news going on about vaccines, much to everybody's delight, a little bit of surprise. We're going to talk in a minute. I think Max and I are both going to be surprised a little bit. There's huge and exciting news going on for vaccines that there may actually be a light to the end of this tunnel. But more questions, tons of questions about what's the effectiveness, because there's all these different ones. We all know more information than anyone has ever known about any drug, vaccine, or anything else. So let's get those answers to your questions so that you know with confidence that actually there's some great things going on and that we have a light at the end of the tunnel. So I'm Sarah Heiner. Welcome today to our Bottom Line Health and Happiness show. We used to be called The Advocator, but I changed the name. Health and Happiness felt so much better. Couple little things as always. If you missed some of this or you want to share this when you're done, there's a whole video library of these in the Bottom Line Facebook page. If it's easier for you, we also have a growing library of videos in our YouTube channel, Bottom Line Inc. YouTube channel. Easy to come to. We have some snippets. We have hundreds actually that I've been doing over the years. So you can come on there and share those with people. If you have any questions today about vaccines, put them into the chat box. We're going to try and answer as many as we can. I know there's a ton of them. My husband actually before this was giving me his questions and I said, I got that one. But put them in the chat box and someone will forward those along to me. This Thursday, actually, normally I do these Facebook Lives on Thursday. Happy Thanksgiving. Please go enjoy yourselves. Stay safe. Enjoy your family. Give your family a hug. Hugs are important as well. And there's a lot to be grateful for, even in the midst of this pandemic. There are a lot of silver linings that a lot of people have talked about, including time at home, time to enjoy your family in a way that you haven't been able to in a long time. So be grateful for what we do have, please. And one more thing. No one can beat this if your body isn't strong. I've talked about this repeatedly. It's really important to have a strong immune system that if you can't pass along a germ if you don't get sick, and you reduce the odds of getting sick if you have a strong immune system. So we actually Bottom Line put together a download of great information from some of our top experts about ways to strengthen your immune system. So download that. It's totally free. There's a link in the chat box. I just want everybody strong and healthy. The doctors aren't talking about it. The media isn't talking about all the things you can do to prevent it. There's a lot you can do for prevention beyond simply masks and social distancing. So can't say anything more important about that. And with that, let me bring on Dr. Max Gomez, my good friend. I will tell you all about him, but I always am so grateful. He's one of the smartest people that I know. Welcome, Max. Let me introduce you to everybody.
Hi, Sarah.
Anyone who doesn't recognize the one and only Dr. Max Gomez, he is, I love saying this, the 9-time Emmy Award-winning medical journalist who's known and loved by New Yorkers for decades. You can see him on CBS News in the evenings with his great and very important medical reports. He has received an Excellence in a Time of Crisis Award from the New York City Department of Health for his coverage following 9/11 attacks. Very near and dear to his heart is the work that he's done on stem cell research. He was the moderator of the 4th International Vatican Conference called Unite to Cure, How Science, Technology, and 21st Century Medicine Will Impact Culture and Society. And that's something that has been a huge accomplishment for Max, and really proud of the work that he's done with that. And as I said, he's one of the smartest people that I know, and he just always knows the answer to everything. You can follow Max, learn more about Max at drmaxgomez.com. So hello.
Hi.
So when you and I last talked in May about what was going on with all of this stuff, you and I both were a little skeptical about vaccines. We talked a lot about treatments. We talked about prevention. Treatments as that was going to be phase 1 because the odds of getting a vaccine are usually pretty slim, certainly in a speedy amount of time. And yet, meanwhile, here we are with 3 vaccines that have passed phase 3 trial and looking extremely encouraging. Are you surprised?
I am. Thank you for pointing that out. I am surprised. I'm pleasantly surprised. Look, I truly hope that this will be the end of the pandemic. But as an expert I interviewed from Yale just last week said, it's the end of the beginning.
How so?
the issues now confronting us, we've now tested it in the case of, let's see, Pfizer was around 40 some odd thousand.
Mhm.
I think Moderna was in that same neighborhood. And
AstraZeneca somewhere. They're all about the same, 30 to 60,000.
yeah,
I think.
they're actually kind of in fits and starts with kind of slightly different chunks being done in different countries.
Mhm.
Eventually, I think they're going to be a total of up to maybe 60,000
Mhm.
people there. Anyway, the end of the beginning is the science part and testing it, doing these now phase 3 clinical trials. Now comes a part that is in some ways almost as challenging is distribution.
Okay.
Distribution and administration. How do you get these things out to billions of people? We're not talking about, that relatively small handful of people that we get flu shots to over a period of, almost an entire winter.
Right.
This is worldwide. The supply chain is difficult. The supplies, the administration, the storage, and so forth. We'll get into that
Yep.
into some detail, but
And the ethics, frankly, which.
that's another very big issue. So
Right.
I'm pleasantly surprised and glad to be such. We'll still see. I was only off maybe by maybe a month at most, I think, here, because I said it wasn't going to happen this year.
I think
So
I wasn't sure it was going to happen this decade, because normally,
well,
I mean, this is really important for people to realize. This truly was warp speed. I mean, it takes 10 to 15 years for vaccines to normally be developed, thoroughly tested.
it's a huge scientific accomplishment,
Yeah.
especially given that uh, there are multiple platforms, if you will, that these vaccines, and some of them completely novel,
Yeah.
ones that have not been used in vaccines, certainly not on a large scale before. So it's a huge scientific accomplishment, but there's work left to be done here.
There is. All right. So let's talk about that, because question number one is wanting to understand these. It's so, it's so funny because people just go and get vaccines. Like, never have people paid attention at the level and gotten the information that they're getting about every detail. I have no idea how the mumps vaccine was produced, right? No one has any idea. And now we're going to talk about some pretty heavy science. Sorry, crowd, you're going to get biology 101 here. Because it's just so on everybody's minds. So let's talk about first the technology. So these two different platforms, because we've got the two on a similar platform. We've got Pfizer and Moderna, and then the AstraZeneca, which is a different platform. Let's do, even though AstraZeneca is the one that most recently, posted its numbers. Let's talk about that first, because that's, I'll call it the traditional vaccine platform.
Kind of.
Well, in terms of what's it called, viral vector vaccines, where they take a virus and they adapt it.
Right. So I hope I get all of the details correct here, but this was actually a platform that the University of Oxford in England had been working on for Ebola and some other diseases before that didn't go very far because, again, it didn't seem to be, it wasn't as big a deal in the sense that these epidemics kind of tended to burn out. And quite frankly, the market wasn't huge, so there wasn't the kind of money that was being thrown at these COVID vaccines. So it's based on a monkey virus.
And it's not, it's standard when they do these traditional vaccines that they get a virus from another species. Like, it sounds creepy. I'm going to get a chimpanzee virus into me, but that's standard procedure. They get a virus and then they alter it, basically.
Yes, it's an adenovirus, it's called, and it's had its genetics kind of disabled in a sense so that it can't reproduce. These viral vectors are really very common in terms of delivering gene therapies and vaccines. This is a very common technology,
right?
Because viruses are really good at delivering genetic material into cells. That's what they do,
Right.
is they work their way into, they're able to be attached and then be taken into a cell, and inside the cell, the virus then takes over the manufacturing, the protein manufacturing machinery of a cell. So in this case, this is a chimp adenovirus that's been disabled. It's been genetically modified, so it's had a chunk taken out of its genetic material so that it can't
get monkey
replicate.
sickness.
Right.
Right.
So and then the other thing that they've done with it is they've inserted the gene or a gene, some genetic material that will cause it to reproduce some of the proteins, particularly the spike proteins of the coronavirus.
Could you say define what a spike protein is? Just
Yeah.
because it's a word that's thrown around, and I keep picturing that, a thing sticking off of a virus, but I don't think
We've all seen pictures
Mhm.
of the virus, right? It's kind of a round ball with all these little red balls or spikes sticking out of it.
Which is what locks in when it attaches to the cells.
That's where its name comes from too,
Right.
by the way. It looks like a crown. It's a corona,
Mhm.
and that's what it looks like.
Mhm.
And those are the little spikes that it uses to actually attach to the surface of human cells, specific receptors on the human cells. As it turns out, they are receptors that are very common in the nasal passages, in the throat, and the linings of the lungs, which is why initially it was thought to be just a respiratory virus. It turns out those same receptors are highly present in the linings of blood vessels, which is why one of the other effects of the coronavirus is this hypercoagulability, meaning
Right.
we produce a lot of blood clots, those little, some microscopic, some very large, and that's why we get strokes, heart attacks, kidney damage,
Right.
liver damage, because these little clots have now formed everywhere. But anyway, back to the chimp vaccine, the chimp virus.
But we digress.
So this virus is kind of a Trojan horse.
Mhm.
It's a delivery vehicle,
Right.
and it's got the genetics a little piece of the genetics of the coronavirus. It gets into the cell. It releases this. It's taken into the nucleus of the cell, where now it will reproduce, or it's become the DNA, then
Right.
gets transcribed to RNA and gets spit out into the rest of the cell, where these little ribosomes, the little actual factories that then will read this genetic material and make some of this spike protein.
Okay.
That spike protein then gets released into the system, into the body, where now the immune system will see it, recognize it as something that doesn't belong there, and make antibodies to it.
So how come this is, when we just said that it normally takes 10 or 15 years for a vaccine to be produced? This is, I'll call it traditional vaccine manufacture. How are they able to do it so quickly? Was it because of the similarity to Ebola?
Not so much the similarities to Ebola, the virus, but it was a similar technique. We've developed the ways to, CRISPR is one of the ways in terms of editing the
Mhm.
genome in the virus, so that we know we can go in there, clip out a chunk of the genetics of the virus so that it can't replicate, and another system or technique, genetic engineering technique, essentially, that can insert the viral genome, the piece of the coronavirus into this chimpanzee adenovirus. Does that make sense so far?
It does. So they basically adapt. They were able to have new technology that helps them speed up that traditional
Right.
technology.
And
If I can
these things,
oversimplify.
right. So again, but a lot of what has allowed it to really accelerate is money.
Yeah.
Because in two things, actually. One is money, so that these clinical trials and the science and the manufacturing and so forth can then be accelerated because they know that if they are successful, there will be a pot of gold at the end of the rainbow.
Right.
The other thing that has accelerated it, which was something that when we spoke before, I hadn't really considered necessarily, but this occurred to me. The way these clinical trials are done, let's say you're doing 50,000 people out there.
Mm-hmm.
You give 25,000 people the vaccine and 25,000 people a placebo.
Mm-hmm.
These are normal, uninfected, healthy people.
Right.
And now you turn them loose, live their life, follow whatever, procedures they are, and then you wait to see how many got infected in each group.
Right.
The fact that that infection is so rampant
Oh, so they can accelerate.
accelerates it
Right.
because they are the people who are either vaccinated or got the placebo. That many more people are going to be exposed, community spread of the virus. So in a sense, the fact that it is so rampant is if you can call it a silver lining, what helped accelerate the results from a 30 or 40 or 50, 60,000 person clinical trial.
So when
And
they test these, Max, they don't give them the vaccine and then intentionally expose them to sickness?
those are called human challenge trials. And that was considered as a way to accelerate the results, where you would take, in this case, it would have to be young, healthy people, give them the vaccine, and then intentionally try to give them some of the
Right.
virus to infect them, and then see how that worked. That clearly has some ethical challenges
Small detail. Okay, fine. Point taken.
involved. But also, the only people you would really try that with are young, healthy people. And
Right.
so it wouldn't be clear whether the vaccine would really be protective for older folks like me, or people of color, minorities, people with pre-existing conditions, who are most at risk for a really bad outcome.
So
Wouldn't be clear. So despite the fact that you could accelerate some aspect of it, you wouldn't really have the answers that you really need in terms of whether this protects you in a community setting and who it
right.
actually protects.
So
So
that's a really good point though,
one
Max.
more thing though about the fact that
Mhm.
out of the 40,000 odd that Pfizer had in their clinical trial, the total number of infections was only, I think, 137.
Wow.
So we're not, even with all the infection all the coronavirus that's out there, we're not talking about a lot of people who actually got sick, but it was highly statistically significant because only it was a small handful, and now it was less than 10 of those 137 were in the vaccine group.
Right. Pfizer was 95% effective, I think.
Right. So
Right.
it's in the vaccine group. All the rest were in the placebo group. So that it looked like it was pretty clear that the vaccine was providing protection.
So you raised a really important point, and then we're going to explain the Pfizer and the Moderna vaccines. There's so many aspects of this, but this is an important point that you talked about, because generally one of the complications with drugs and vaccines is this testing across different groups.
Mm-hmm.
And different diseases and different ages, and that very often trials are knocked because it hasn't tested for different segments of the population.
Right.
How much for all three of these have they been able to test across the segments? Because again, the people that are getting sick are older, obese, these other comorbidities. I want everybody to know that the vast majority of people that are getting sick or seriously sick from it sick from it, have these other factors. Have they been able to include those groups, including minorities as well, which also are indexing high in these tests?
In the case of Moderna and Pfizer, they both were, and in fact, I believe Moderna had to pause their trial for a short while not because of any safety or adverse events, but to reinforce their clinical trial site, saying we need more minorities to be
Mm,
part of the clinical trial. Pfizer was able to, they say, complete this across all sort of racial, ethnic,
right.
socioeconomic groups. The AstraZeneca one, that's less clear
Yeah.
whether or not they've been able, they really have a good representation. The results that were reported out this past week from AstraZeneca were really based on two relatively small trials so far in Brazil and the UK.
Okay.
Um,
And
so and one of the criticisms that I read from some of the British scientists was that it was a very white population that they had
yeah,
tested it in, and so but presumably some of that will be accounted for. They're also testing it in
well,
Japan, the U.S., Russia.
Brazil,
Um,
not so white. I mean, Brazil has,
it depends on where you go
yeah, okay.
in Brazil. So
But
uh,
that's a really important factor, again, as, you know, in a little bit, we'll talk about in terms of decision trees, in terms of getting the vaccine on and how safe is it and the efficacy. And that's a critical factor in terms of the scale across which that it's been tested. And let's just say also the other detail on the AstraZeneca, and then we'll talk about the other two. You said that it was two smaller groups, and the way they reported the numbers, they said up to 90%, but on average it was 70%. So why don't you just clarify what that meant real briefly
yeah,
to people?
this is the perplexing part about this particular vaccine, and I've spoken to some immunologists about it to try to get some explanation for it, and they didn't have a good explanation for it. There was one group that received one dosing schedule or regimen, had a 60+% effectiveness rate, and a group that got a different dosing regimen had a 90
Right.
plus percent. So they averaged out to what they reported out as 70% effectiveness. Okay.
Yeah, but you would never average it. It's really, did this one work or this one work?
Right.
And
So
that
what,
the 2 dose, but it was like
right,
a
what was
full and a
confusing,
half or something.
was the lower effectiveness dose, a 60% or so regimen. It's 2 shots, full dose first, wait a couple of weeks, full dose for a second shot. The higher effectiveness was a half dose in the first shot and then a full dose.
Interesting.
From a biological mechanistic point of view, the immunologists say I don't have a good, including Tony Fauci, said we don't quite understand why a lower dose first and then the full dose booster would be that much more effective
Right.
than the full dose twice. So that's one of those scientific things that they're going to, curiosities, if you will, that they're going to have to take a look at
Got it.
and
Okay.
try to understand that a little bit better.
So some questions still going on in the AstraZeneca one.
Right, and again, those 2 trials only account for, I believe it was a little over 20,000 people. Eventually, they will get to 60,000 when they bring in the results from the US, Japan, Russia. There's, I think, 1 or 2 other countries.
60,000 per panel or 60,000 total?
60,000 in total.
Okay. All right.
From all of the different countries.
So you really have 30 with each of the different dosing.
Correct.
Yeah. Okay.
Yes.
All right, let's talk about the Moderna and the Pfizer, which are entirely new technology, fascinating technology, and one that seems to, if this works, although they've been working on it for a while, this technology, if it does work, can revolutionize the future development of vaccines.
Absolutely could. And then let's not forget later to compare the sort of the pros and cons and pluses and minuses
Oh, yeah.
between these different vaccines.
Look at it. It's so hard. I'm trying to get all the information,
No,
watch o'clock. So, because I want to get all of it out without, you and I could talk like for hours on this, but
So
Yeah.
it's interesting about, oh gosh, it's probably a good 4 years ago or so. I spent some time on the phone a couple of times with one of the founder, and I guess he's CEO of Moderna, Stefan Bancel, um, eh, talking about, oh, he has this new platform and this idea, and mRNA, Moderna is sort of the, a cute little play on words that they're using. And, it sounded sort of like, well, that's nice, but call me when we've got something that we can actually, pin our hats to or hang our hats on. And then suddenly they became, they'd been working on this technology for a while, and then suddenly it became hot when it appeared that this was a way to accelerate the production of this vaccine. So both of them use similar things. The coronavirus is an RNA virus, unlike all of the cells in our bodies, which use DNA as their instruction manual. Viruses, they're called retroviruses. HIV is also a retrovirus, by the way, uses its RNA. So what it has to do, it has to get into a cell and again, hijack some of the machinery to then have it transcribed into essentially all the proteins and things that make more viruses.
Right.
And that's how a virus does its dirty work. It hijacks a cell, gets it to turn into a virus making factory so that it, boom, spills out
Right.
Billions and billions and trillions of these things. So what Moderna and Pfizer have figured out is they figured out which part of the virus's genome, the RNA, the gene that codes for this all-important spike protein that the virus uses, right, to attach to cells.
Mm-hmm.
They figured out, and this is the really ingenious part, they figured out, because mRNA is notoriously unstable. You can't just take a whole bunch of it, inject it into the body and expect it to do anything. It'll all fall apart very quickly.
And why is that? Because it's fake?
It's, yeah, I mean, it's it's just not, it's not protected in the cell, in the body. It's, it's inside the cell. It's where it belongs. It's in the right environment. If you just inject it into the body, there's too much stuff going on there. It'll degrade. The pH may be off. There's a lot of different reasons why it may break down.
So is this why, Max, they've been working on this technology for a long time, but they have yet, this is the first time they're actually finding success and able to take, because of the sensitivity of the mRNA?
Well, the theory has been out there for a while. What if we could do this?
Right.
But the mRNA messenger, M starts messenger RNA, because normally that's what gets made in the nucleus of the cell from DNA. It's the messenger that gets out of the nucleus, out into the rest of the cell where it makes these proteins. The ingenious part is they figured out how to protect the mRNA, the part that they want that will make the spike protein, figured out how to protect it. They microencapsulate it in fat, in lipid, these little tiny microcapsules, so that it is protected. And that's what allows it to be protected, get into the system. That's what gets injected. And also these little fat globules are very easy or likely to incorporate or attach into the cell membrane of cells. And then it delivers the mRNA into the cell. Right? Got it?
Yes.
Now it's in there, and now that mRNA can turn into, it is now the code that makes the cell make more of the little, maybe not the entire, but parts of the spike protein. It's just the spike protein. It's not the whole virus. So it's not going to do you any harm, but it's the part that the body will recognize as number one, foreign, And number two, it's the part that is essential for the virus to actually attach to cells. So when this gets spit out from the little cell factories that have been hijacked to turn into little mini spike protein factories, it gets spit out into the body. And now the body recognizes this spike protein as antigenic, as something that produces an immune response, right? And it starts to make, and so the antibody cells, antibody producing cells see it and make antibodies against it to neutralize it. That's important, but even more important than the antibodies. Antibodies come up and then normally will wane over time. So even if they are neutralizing, they're not going to give us this long-lasting immunity, which is what we need. If we get a vaccine and and over a period of a few months, the immunity wanes and goes away, then we really haven't accomplished all that much. It also seems to be that the immune system now is able to educate itself. Some of these different cells, there's presenting cells, T cells, B cells, to form what are called memory cells, T cells, that will remember what the bad guy looks like. Sort of, they have a photographic memory of the wanted poster in the in the post office.
Which is
And
that's their job.
right, that's
Right.
exactly their job.
Right.
So that if and when they come across the real virus later on, they will both develop antibodies, but the T cells will also be the killer cells that will start going after them. And that's what provides the long-lasting immunity that we get when we get smallpox vaccine, others, some of those things. Some require boosters over time, but basically that's the really important part, is that they make these memory T cells that will give us long-lasting immunity.
And do they have any evidence yet for all three of these vaccines that there will be lasting, or do they still not know how long the immunity?
There is evidence that they make T cell, that they generate T cell immunity.
Okay.
What we don't know is how long, because it's, they've only been testing them for maybe 3-4 months, 6 months at most. Yeah. So we don't really know. We don't really know how long it'll last. It's not like the flu, which we need a flu vaccine every year, because the flu virus and virus strains mutate that quickly and become that much different that the T cells don't always recognize them.
And they don't think that I know they've talked about this virus mutating somewhat, like becoming less deadly, but it hasn't mutated in the way that the flu mutates. So this is a more stable virus in that regard.
There have been different strains. They've mutated some, but it appears that they haven't mutated enough for it to become an issue that the vaccine wouldn't work. It appears that this spike protein piece of it is so important to it that it is conserved. That's what they need to hang on to, and that's what all of the vaccines are basically going after.
So now, Max, is there any concern, because what they've produced on this is...
All right, I'm going to turn on a light here because it's getting dark.
Go
ahead, I'm listening.
You need the giant photo spotlight that I have on me.
Well, I have. Oh, okay. I don't know if that
Let
was.
me also say, while you're just messing with your lights, that I see that there are a bunch of questions coming in, so I'm going to try to move them in, bring them in as the conversation they come into the conversation. So I see them: Carol, Kevin, Chuck, Carly. I see them all. So that's what I'm doing. When I look down, it's not like I'm, playing with my phone. I'm going to call Max for the moment, and this may be a bastardization of language, but the AstraZeneca, I'm sorry, the Pfizer and the Moderna. Okay, so where they've got man-made genetic. They found the genetic material and they man-made the RNA, right? The messenger RNA, kind of, right? Versus AstraZeneca, where they've taken the viruses that they know, they grow them in a lab, and they genetically modify those in that way.
Right.
When they're making this man-made RNA, do we have it? We talk about genetically modified food and things, is there any reason to have concern that the man-made version isn't natural and will be introducing any kind of odd response, odd effects, or anything else long term, or they have no idea? And do you think that's something that people should be concerned about?
That was clearly a consideration
Hmm.
early on, that, what we're doing, it's a genetic based vaccine. What will it do? Are there, as they like to, the geneticists say, off target effects here? It appears to not be an issue so far,
Okay.
that they actually appear to be extraordinarily safe at this point. That said, one of the reasons you do 30, 40, 50,000 is to try to find the tiny little effect that might get lost in the noise, of 30, or of
Right.
just doing, a few hundred people or a couple of thousand people. And there will undoubtedly be some issues that pop up, because they always are. They always do.
There will always, nothing will be 100%.
When you start vaccinating not just millions, but billions of people,
Right. Right.
all of which, each of which may have their own individual biological quirks,
Right.
uh, that might, trigger some sort of an off-target effect. But the piece of the genome that we're talking about is relatively small. It's actually very small compared to, the rest of our chromosomes and genetic materials. And they're pretty good. If it's not precisely a copy of the mRNA that the virus uses, then it won't be effective. Then it
Right.
won't make the
Right. They
right
won't respond. Okay.
the right thing. So in that regard, it's a pretty good copy. Um, will there be some effects that show up down the road? I'd be surprised if there weren't. But so far, none of that seems, other than, soreness, a little fatigue, a little malaise, just like any vaccine for a while. Other than that, so far, it's been surprisingly safe.
Yeah, actually, I just wanted to say, so adverse effects, from what I read, that's exactly what I've read, that it's been a little malaise, soreness, a little bit of fever, perhaps because your body's reacting and
Yeah,
doing
that's the
work.
immune system.
Right. But overall, I think certainly on Moderna and Pfizer, that's all that I've seen reported at all. I think AstraZeneca, I saw something about a little bit of an adjustment in the white cells. There was something that came up on that.
Maybe, again, that's one of the reasons why I get a lot of calls from friends and families and strangers, saying, "Are you taking the vaccine?"
Right.
And I said, I want to see, all of the data, the full data set be evaluated, not just the press release from the company's
Mhm.
data set. That's not to say that they're hiding anything, but, the vaccine committee meets next month, early December.
Mhm.
And that has some very serious, legitimate vaccine scientists, immunologists who I respect,
Right.
who will not rubber stamp anything.
And there was years ago, there was a knock on getting FDA approval for things because, at least in the drug manufacturers, I recall, you didn't, like this happened with Vioxx, where you did not have to disclose all of your research. So it wasn't like they lied, but they didn't disclose all the research that showed with Vioxx that they had heart conditions. I think that law changed so that anything they have has now got to be seen.
Right.
Is that,
I mean,
there's far more transparency now than there used to be.
right. I mean, look, to be the cynic, as some people out there will be, you can always try to, play fast and loose with the data.
Yes.
Just because there's a law that says you shouldn't, and we have to have it, doesn't mean that they will. That would be extraordinarily stupid, I think is the right word, on the part of these
Right.
companies, to try to pull that off, because eventually it'll come out and it will ruin everybody. So let's hope nobody tries to pull a fast one on us.
How, I'll use the word extraordinary, I don't know if that's the right word. Is it that these vaccines are getting 90 and 95% effectiveness when, again, the flu vaccine is 30 to 60%. I think most of the childhood vaccines are closer to the 90, 95. Like that, these are good numbers, no?
These are fabulous numbers. I mean, they are beyond most, even the experts' expectations. I
Mhm.
think it's beyond even the company's expectations,
Right.
quite frankly, that they were getting this kind of protection, again, based on what are still sort of small numbers compared to what we're eventually going to be looking at. But yeah, it's really pretty remarkable. Again, we have to see how long it lasts and whether the 90 or 95% really holds up. When you start spreading it out over a much larger population. But that's really the FDA had said if it hits 50%, it would be enough to grant it at least emergency use authorization and perhaps
I was just going
full
to ask
license.
what their target was.
The target was 50.
Wow. Okay.
It was 50, and they blew past that easily.
Now, Max, I think I saw or heard, maybe when I was talking to Jacob Teitelbaum last week, that if you were, I want to say zinc deficient, that you had a greater, like, if they gave you zinc before you got the vaccine, that it was more effective? Or am I mixing my metaphors? I might be remembering wrong, but I thought there was something that I'd seen about connecting the dots between zinc deficiency and the effectiveness of the vaccine.
Run that by me again, that if you got what before which?
Zinc before you took the vaccine,
If you
or
got
something
what?
like zinc supplementation, because zinc deficiency is so connected to COVID. And that
Oh,
I might,
zinc.
yes, zinc, yeah. But I might be half remembering something in the haze of all my conversations.
I don't know. I haven't seen any data on that
Mhm.
directly, and I don't know if they teased that out
Right.
in the trials.
Yeah, I'm sure they weren't. I'm sure they were focusing on that. We've seen all the data about D deficiency and zinc deficiency impacting somebody's vulnerability to sickness and serious sickness.
Right.
So maybe they go back and look at that again as part of
Yeah,
the comorbidities, like if you're obese. Because what I'm thinking about is, someone asked me, Kevin asked me a question about if you're immunocompromised, is it safe for me to get the vaccine? So again, healthy person, relatively easy to get the vaccine. But if you're immunocompromised, if you are obese, if you do have diabetes, if you have any of these comorbidities, are you at any greater risk in getting them, or is it safe among that crowd?
it appears to be these. In fact, I've had this discussion for some other reasons with doctors, and yes, immunocompromised people are encouraged to get the flu vaccine, for example, uh, but the dead virus vaccine,
Right,
the nasal spray version is an attenuated virus,
right.
which means it's just been weakened, but
Mhm.
it's still a live virus. That's not a good idea. But none of these are.
So these where it's just looking like a duck and quacking like a duck, so your body learns what a duck is
Right,
and learns to go attack that duck when it comes in, but it's
right.
not
Without the duck being able to make more ducks.
right. It's a castrated duck.
Okay.
Sorry. Ay, ay, ay. Yes.
All right. So you want to should we compare the vaccines?
Let's talk before we get to comparing. Let's talk about this whole distribution thing and cold thing. Okay,
Okay.
so let's talk about that.
Okay. Because some of that is they're kind of intertwined.
Okay, then let's forget it. Let's not do the whole science. Nobody, it's so funny. As I said, we all know far more about this. I have no idea how they distribute a flu vaccine, an HPV vaccine, or any other. And now we're all going to worry about refrigeration for things. So yes, let's do pros and cons. I've got a few questions. We'll run those afterward. So we'll
Okay.
just run them down. Ask Dr. Max.
All
All
right.
right. So pros, cons, go.
So Moderna and Pfizer, again, because RNA is very labile, very unstable,
Mhm.
and even the little fat microcapsules are kind of unstable. Yeah, at room temperature, they become, liquid and
Right.
liquefies, and then everything, falls apart on you. The disadvantage to the Pfizer vaccine is that it has to be kept at really deep sub-zero temperatures,
Right.
very cold. And
Right.
the problem there is that there aren't very many places, at least at this point, that have the kinds of freezers that will keep them at that
Right.
point, at
And
that
this is the
temperature.
temperature, it's like 90 below negative 90 Celsius, which is like what, 120 or something Fahrenheit,
Something,
negative, something crazy.
it's cold.
Right.
It's a dry ice cold.
Yeah.
Um, uh, Moderna, and again, the differences are it's the proprietary little fat globules that seem to make the difference,
So it's the way they
because
made the fat.
because
Okay.
the RNA, the mRNA in the middle is essentially the same.
Mhm.
Um, the Moderna doesn't have, just has to be kept at, I don't know, about -4 Fahrenheit, I believe it is. So commercial freezers generally should be able to keep that. So that means that it makes it, the transportation and the storage of it much easier.
Mhm.
And apparently, one of the things that they tested was even after it's thawed or kept at regular refrigeration temperatures, not frozen temperatures, it seems to be stable for up to a month even.
Wow. And I think I saw Pfizer was stable for up to 5 days or something. It's a
Right.
little more vulnerable.
Yeah, it's a little more vulnerable. So that makes, again, distribution and storage a bigger challenge
Mhm.
for both of those. Not impossible, but again, remember, we're talking about getting it out there uh, to the boondocks in rural areas,
Mhm.
as well as in big cities or whatever. So that makes it challenging. Manufacturing is an issue. These things are not easy to make. They're expensive, and then you have to keep them at that temperature, transport them at that
Right.
temperature. All of these things are part of the issues of distribution. Now, the AstraZeneca is uh, cheaper to make and stable at regular refrigeration temperatures. So even though it may not turn out to be as effective in terms of uh, protection, if you still get 70%, maybe they'll get more if they can figure out why the half dose is better than the full dose. Um, that might make it a much more, a better candidate for distribution in developing countries.
So, and when you say cheaper, are we talking, I'm making up numbers just for scale, $1,000 versus $5,000 per dose? And
Um,
what, I have no idea what the scale is, and I mean, then there's talk that the government's going to pay for everybody to get vaccinated anyway.
well, here,
Yes.
the cost for, Africa, for parts of Asia, for parts of South America, the difference is a big deal.
Right.
Because these are it's a global pandemic.
Yes.
And only if, just because we have managed then, say, to beat it down in the United States, but there are still hotspots around the
Right.
world, the virus does not recognize or respect national boundaries. It
Right.
will move, as we saw.
So there are a lot of questions about whether people will have a choice of what vaccine, so now if they've got three, and again, I don't know how many people make the chickenpox vaccine. I don't know how that works. So if I go to the grocery store, I can pick Post or Kellogg's Raisin Bran. So is this going to be an individual choice when they go to the doctor? Is it a question for people to ask their doctor about which one, or is it possibly going to be about distribution? And the more shelf stable one will go to the warms. And if I live up in Minnesota, by golly, I can go take Pfizer because they just stick it out on the back deck all winter long.
Right. Those are questions that remain to be answered. Quite frankly, this is why I was saying the distribution issues now are going to be hard to work out in some ways. You go to the doctor, you may not get a choice of vanilla, chocolate, or strawberry. You might only get vanilla, or you might only get chocolate. It depends on uh, distribution, how many doses are made, what the individual medical systems, hospitals, doctors' offices can get their hands on. Initially, you're not going to see it in the doctor's office. I don't believe you're going to see it at, at big medical centers
Right.
that can actually handle it, and do it, and do it correctly. So that part of the district, in terms of, I didn't finish up the cost issue. That has also not been worked out. AstraZeneca committed way back when to making all of the initial batch of a few hundred million, I believe it was, at cost,
Mhm.
not making any money.
Right.
They will eventually,
Right.
after that first batch of trying to
Right.
get it, trying to get it out there. They won't be cheap, but I don't think they're in the thousands of dollars range.
Yeah. Okay. I
They
saw,
haven't
I
announced
saw
pricing
some,
because they haven't gotten to that point.
I saw some numbers in terms of how many doses they'll have. It was interesting, actually. AstraZeneca said that they're projecting by the end of 21 to have 3 billion doses, to Pfizer's 1.3 billion, so far fewer, and then Moderna's 1 billion. And I don't know, is that what's
They're harder to make.
driving those numbers? Because why
Yeah,
is it harder to make once they're making it? The fat on the mRNA?
you've got to generate, I mean, all of these are, people forget how complicated, not forget, they don't realize how complex the manufacturing process is. In the case of AstraZeneca, you have to have, you can get plenty of the chimpanzee virus, but then you have to genetically clip out and disable the virus. You have to make the chunk of the RNA. You have to get it into the chimp virus and get it to incorporate into its genome. Then you have to test it to make sure that that you've accomplished what you thought you were going to accomplish. And then you can manufacture a lot of it, put it into other cells that make lots of it. But now you've got to then extract all of that, purify it, test it for potency, bottle it, store it, ship it. Likewise with Moderna and Pfizer, you've got to manufacture the little mRNA, which actually these days is surprisingly not that hard.
I was gonna say, there you have the recipe. Like the chimpanzees, you have to keep gathering more virus from nature versus mRNA. It's like, once you get that first batch of cookies on the baking line, the recipe doesn't go.
Then you've got to take each little snippet of mRNA and do that microencapsulation. And again, you've got to purify it. It's got to be done in a very specific way. And as far as getting enough monkey virus, you don't have to I keep saying chimpanzee virus. You don't have to go to chimps. Once you've got a stock of that, you can reproduce that in the lab as well.
So right now, if somebody was handed all three, it seems like it's too soon to say that they all seem to be pretty good and there's not a significant advantage or disadvantage given the safety profiles thus far and the effectiveness numbers so far. Again, AstraZeneca, I'm just thinking about assuming the 90% group would be, assuming that's replicatable or extendable. So that in terms of people's fears of which one should I get, they all seem fairly comparable.
It looks that way. And I think initially it's going to be availability, what's out there and what can you get your hands on. And then comes the decision of who gets to the front of the line.
Right. Well, now we're at the ethicists, but again, I mean, yes. Okay. We're not going to do ethics today. We're going to just do facts today. Let me do some of these questions that people have been asking.
Okay.
Some of them were a little off topic, so I'm not going to, in terms of, all right. So we talked about from Carly. Thank you, Carly, in terms of how we know what you're getting. We talked about that. Chuck asked about how long after getting COVID would I have a temperature, but that's a little off topic, Chuck. But I will want to say again, people getting a fever after they took this vaccine, that's not abnormal. And that happens in all sorts of vaccines. So that's,
right.
Again, people don't know what
system responding
So when you get a headline that says people got a fever, or they got, they had a pain afterward, it's what happens. It's your body responding to, and it's doing the work. So don't be all alarmed by it. If they're spiking 105 fevers, that's a different thing. But these are mild fevers that people are getting. Correct? Okay.
Yeah.
I talked about Kevin, who wants to know about if he was immunocompromised. Carol has been doing her homework. There are 2 cases of transverse myelitis, and you're going to have to translate that one, Max.
Right.
The AstraZeneca trial. Is that a huge concern? So translate transverse myelitis, please.
Transverse myelitis is an inflammation of the spinal cord.
Okay.
That can be very serious, can lead to paralysis and even death if it gets bad enough. There was that one case of, I don't know that the company ever 100%, when we reported that it was transverse myelitis from some sources, they said, well, that hasn't been confirmed, which is not an easy thing necessarily to confirm. They apparently concluded, the company and its, the data safety monitoring board concluded that it was not related to the vaccine.
Okay.
It's a very serious event, but if you're doing 60,000 people, some are going to die of a heart attack, some are going to have a stroke, some are going to have transverse myelitis, is pretty rare. The question is not whether they got it, the question is, was it related to the vaccine?
Right. And this, again, I remember one of the, I forget which one of them had been paused briefly because I think someone had died, but again, that had nothing to do whatsoever with the vaccine.
And again, all of that is very common in these large trials, and you have to take a step, take a deep breath, evaluate it, and figure out as well as you can, were they related?
Yeah, and in fact, I think the person that died was in the placebo group. I don't think they even had gotten the vaccine, as I recall, and I don't remember which trial it was. So let's go back to the original question. How encouraged are you? How good should everybody feel about this?
I think at this, I'm much more encouraged than I was, a few months ago when we first talked. The safety profile seems to be pretty good. The effectiveness in the short run seems to be very good. So there are 2 questions that I see that might be obstacles to really making this the answer to the pandemic. One is, how long is the immunity good for?
Mm-hmm.
And we won't know that for a while. But the other is the uptake. There is so much anti-vaccination, I hate to use the word fever, out there. And it's been—
Are you talking about the political debate of it, or just anti-vaxxers in general?
Well, the anti-vaxxers in general were there. And then the whole thing became politicized, which kind of added fuel to that particular fire. So now it's interesting. Now you've got anti-vaxxers and some fuel there, but then some of those may say, well, yeah, but this is something that, the whole world needs, and maybe you'll have people crossing over between different groups. But uptake is a big issue. And there was the guy from Yale, from the Yale School of Public Health I interviewed last week. They published a paper on all of the issues and obstacles or challenges of distribution through public health systems. And he said what we really need will be a very big public education effort. We've done the science now.
Right.
If people don't take it, you're not going to be able, unless there will be some, and this was part of a discussion that I also had not too long ago when I did a webinar, is will some people be able to require employees, for example, to get vaccinated?
Right.
Those issues can get a little thorny. They haven't been really well resolved in the courts. If you're going to be in a cancer ward or an HIV treating patients or whatever, can the hospital say you must be vaccinated? Um, there have been, healthcare workers who have refused to get the flu vaccine, for example,
Right.
that sort of thing. So it will be an issue because we will need the vast majority of the population to be vaccinated and be hopefully immune for an extended period of time in order to really be able to beat down the curve and beat the pandemic.
I was going to say, so what if, I'll call it 50%, because again, there's 5% of the population that's getting, I'm mixing I'm extreme numbers here, but I'll call it 5% of the population are getting 95% of the sickness. If it's not 95%, it's 92%, right? So that there's a narrow part in the highest vulnerabilities.
Yeah.
So why do I need necessarily to vaccinate otherwise healthy people who are taking care of themselves, they've got strong immune systems, et cetera, et cetera? And if you have 50% of the population that gets vaccinated, is that enough for herd immunity? Although then it's not running around so that people aren't absorbing the sickness the same way that when it's like out in the environment.
Your 5% or 8% is a number of the people who will get sick enough to be hospitalized and be at risk for dying. And most people who get infected will not be in that category and will recover from the acute infection. The wild card, the joker in that deck, is that even people who get sick or get infected and recover may suffer long-term, long hauler syndrome, as it's called.
Right.
So that, yeah, I'm over the acute infection, but I've still got brain fog. I still get dizzy. I still develop fevers that spike out of nowhere and go down. My fatigue is overwhelming, that sort of a thing. So that's one issue. The other issue is even some young, healthy, apparently normal, whatever that is, people who you would think would be just fine, still get sick. So you don't know
everything. Yeah.
So you don't know, who it is. Now, herd immunity varies from the percentage of the population you need to be immune to truly have herd immunity varies with the virus. I've heard it said, the estimate has been for corona in the 60, maybe 70% range. For measles, it's over 90%. Have to be immune, have to be vaccinated in order to truly have herd immunity. So the 60, 70% number for corona is really kind of an educated guess. That's a guesstimate. We don't really know that because we've never been close to that. And we don't know if that's enough. That's based on, how many people one individual can go ahead and spread to.
They are not, right.
It might be, but that's still a big number. If you've got 330 million people in the United States.
180 million or so.
Yeah, you're talking, 200 million plus people who need to be immunized.
Right. All right, Max Gomez. A lot of questions, a lot of good news. I really am extremely encouraged.
I really am too. Now, the challenges now are logistics and distribution, and then, as you mentioned, ethics. Who gets them first? I'll say one quick thing about that, which is everybody assumes that the first people to get it should be first responders, the people in the hospitals, the nurses, the techs, the doctors, and so forth. And that's kind of what I would normally expect. I did a Zoom, it was actually a Zoom cocktail hour with a good friend who's a big nationally known immunologist, also from Yale, different guy, from Yale. And he said at the Yale medical system, which, some months ago was completely overrun with cases and things like that, after the initial wave, they said, not their residents, not their doctors, all of the people, these first responders have actually not gotten sick.
Wow. Is
So
that
we said, maybe they're not the ones who really should get, that's probably not going to fly politically, but, but maybe they really aren't as big a risk. The people in what they call congregate housing,
Mhm.
nursing homes, prisons, dormitories, other things of that sort, are probably at much greater risk. But again, those are some of the other thornier issues that really aren't necessarily science, they're societal.
Right. Well, and then there's the other side of it is who do you force, or you invite them to the party, but
Right.
then giving people the option, people who want to get it versus people who are not necessarily as inclined to run on the front of that line.
Yeah.
And
As,
again, I think you made the important point about the politics of it. I mean, it's undermining all the conspiracy theories and the we versus they, and because it came from that, stop that, people. Like, it's just destructive. Like,
it
we all
really,
want the goal of being out of these caves.
absolutely.
Yeah.
And what's interesting is Arthur Kaplan, who's a bioethicist at NYU, said, you've got the anti-vaxxers who were in theory against vaccines until there's an effective vaccine that might protect them. And they will go very quickly from being an anti-vaxxer to, why is that guy ahead of me in line?
Always,
Yeah,
always. Right. All right.
we will have enough for another discussion soon.
We will have you back if you don't mind, another day as
I'd
this
love-
unrolls. All right, Max, thank you so very much. All
My
right,
pleasure.
anyway, if you've got any additional questions, you can put them in and I'll see if I can beg Max to give me an answer to you. He's always so nice, so I bet he'll do it. Anyway, so
Last thing,
yes,
to quote, was it Tony Fauci? Might have been, wear a damn mask,
all right,
please. That really does make a difference. And it's got no side effects, trust me.
and wash your hands.
Well, yeah, but
And don't touch.
it turns out because it's airborne, the mask is even more important than washing your hands.
Okay, you heard it here. All right, thank you, Max. Thank you, everybody. Thursday, you're off next Thursday, the week after Thanksgiving. We are going to be talking about the PCR test and questions that you have about the testing and all this testing that's going on. So come back next Thursday. You'll see it promoted in the Facebook, and have a wonderful Thanksgiving. Thanks, Max.
You bet. Bye-bye.
Bye.